Okay, now we're starting chapter 3 with measures of central tendency. A measure of central tendency numerically describes the average or typical data value. We hear the word average in the news all the time. Well, we're going to discuss the three most widely used measures of central tendency: the mean, the median, and the mode. In the media, average usually refers to the mean, but beware. Some reporters use average to refer to the median or mode. These three measures of central tendency can give very different results. So one average could be used to support one position, while another average could be used to support the opposite position. So you really need to know which average is being used, and be wary if they just say average instead of specifically say mean, median. Okay, the arithmetic mean, right, of a variable is computed by adding all the values of the variable in a data set and dividing by the number of observations. So the population arithmetic mean, which is called mu, Greek letter mu, is computed using all the individuals in a population. The population mean is a parameter. Remember that? P for parameter means it goes with the P for population. Okay, so once again, when you hear the word average, you typically think of the mean. You add up all your data values and divide by how many there are. So the sample arithmetic mean, here's the symbol for it, and it's pronounced X bar, is computed using sample data. The sample mean is a statistic sample. Okay, so it's the exact same formula. Just note capital N is for population, likewise mu is for population. Lowercase n means sample, X bar means you're talking about sample. So while other types of means do exist, the arithmetic mean is generally referred to as just the mean. So that's what I'll do from here on out. And we use the Greek letters usually to represent parameters, okay, and Roman letters usually to represent statistics. Okay. Whoops. Okay, so here's an example. The following data represents the travel time in minutes to work for all 7 employees of a startup web development company. Okay, compute the population mean of the data. Okay, so, and it is population because all 7 employees, that's all the employees at this startup company. So let me get a pen. So if we're going to compute the mean, you just add them up. 23 plus 36 plus 23 plus 18 plus 5 plus 26 plus 43, and divide by how many there are. 1, 2, 3, 4, 5, 6, 7. Right. Okay, so let me grab my calculator and do that. So I got 174 divided by 7 is 24.857. So is 24.857. Okay, so now B says then take a simple random sample of size 3 employees and compute the sample mean. Obtain a second simple random sample of size 3 and again compute the sample mean. Okay, so let's try to keep this straight here. So once again, we're going to do this on our calculator, a simple random sample. So I need to enter a seed number on my calculator, and you can find instructions, some technology tips on these things in your modules next to, when we talked about the getting a simple random sample earlier, we just used the random number table. But in 1.3, so by that video of 1.3, you can find the instructions on how to get your calculator to do a simple random sample. So first of all, we need to set the seed for our calculator. So I'm going to come over and do that. I've got to go into math, probability, and all the seed is, by the way, I'm just going to use 10 for my seed. Oh, and all the seed is, by the way, it just tells your calculator where to start. So your calculator will generate just that list like we saw in the random number. And if I say 10, it says, okay, start with the 10th random number that you actually generated. All right, so it's just a starting place. So you can enter any number that you want. All right, so I stored it. Okay, and then, sorry guys, I know you can't see what I'm doing over here on my calculator, but you can be doing it on yours too after you look at those instructions. All right, so I've got the TI-83 plus. That's why I'm hesitant to say too much out loud, because your steps and mine might be different. Okay, and we have 7 values to choose from. Okay, so the first random number it came up with, and let's just label these 1, 2, 3, 4, 5, 6, 7, was 3. So our first random sample I'm going to do in red. So I'm going to use 23 plus the 5th one, 5, and then the first one, 23, and divide by 3. Okay, I'm going to go ahead while I've got my generator going and do the second random sample in green. Okay, so it says take the 3rd one, the 6th one, and the first one. Interesting. Okay, so what's this, 4651 over 3? So 17. And over here we've got 46 plus 26 divided by 3, or 24. Okay, now it says compute the sample mean again. So let's do sample mean here. 17 plus 24 over 2. $20.5. Okay, that makes sense. Computing the mean, you just add them all up, divide by how many there are. So here's our population mean, and this is a sample mean because I took it from the samples. All right, it helps to think of the mean of a data set as the center of gravity. In other words, the mean is the value that if we drew a histogram of this data, the mean would be the balance point where you've got equal weight on each side. So the balance point. Okay, a second measure of central tendency is the median. So the median of a variable is the value that lies in the middle of the data when it's arranged in ascending order, right? We use a capital M to represent the median. So the steps to find the median is first you arrange the data in order, okay? You find out how many observations you have, find the one that's in the middle. If the number of observations is odd, then the median is going to be that data value that is exactly in the middle. But if the number of observations is even, you're not going to have one value directly in the middle. So you're going to have two in the middle, and you're going to take the mean of those two observations. So you can find the position of the median. Now, sometimes people get confused and think this is a formula to find the median. So be careful about that. This just tells us the position of the median. If I have 12 data values, right? 12 plus 1 is 13 divided by 2 gives me 6.5. So that means, oh, the median is going to be halfway between the 6th and 7th. Right, and I would find that mean of 6 and 7 and get exactly halfway in between there. If I had 9 data values, 9 plus 1 is 10 divided by 2, it's going to be the 5th value when they're in order. Okay, so let's compute the median. The following data represent the travel time in minutes to work for all 7 employees of a startup web development company. Find the median. So the first thing I have to do to find the median is put my data in order. So 5, 18, 23, 23, 26, 36, 43. Okay, there's 1, 2, 3, 4, 5, 6, 7 values. So 8 divided by 2. The median is the 4th one. 1, 2, 3, 4. So the median is 23. This one says, suppose the startup company hires a new employee. The travel time of the new employee is 70 minutes. Determine the median of the new data set. Okay, well, we just added a 70 to the end, so it's still going to be the same order. 5, 18, 23, 23, 26. And that's just a coincidence on this that it just goes to the end, but it's because 70 is the largest value, so it will go on the end. I now have 1, 2, 3, 4, 5, 6, 7, 8. So 9 divided by 2 is 4.5. That means 1, 2, 3, 4.5. My median is halfway in between 23 and 26. So I have to go over to the side and calculate that mean. Add them together and divide by 2. So 49 divided by 2. So what's that? 24.5. Okay, so that's the mean for this new data set. Okay, so notice there's 1, 2, 3, 4, 1, 2, 3, 4 on each side of the mean because the mean's not an actual value. Here there's 1, 2, 3, 1, 2, 3 on each side of the mean, on whatever the mean is. It's right in the middle. Okay, so the following data represent the travel times in minutes to work for all 7 employees of a startup web development company. Suppose a new employee is hired who has a 130-minute commute. How does this impact the value of the mean and the median? Okay, so let's do the mean first. I need a pen first. All right, so the mean is 23 plus 36 plus 23 plus 18 plus 5 plus 26 plus 43 all over 7. Should have kept this information from a while ago, but that's okay. Let me see if I've got in my calculator to go back to it. No, that's fine. Let me just redo it right quick. And that was 174 over 7, which was, yeah, 24 point, get around that to 8.6 this time. Okay, so now if we do the median, okay, 5, 18, 23, 23, 26, 36, 43. Okay, 1, 2, 3, 4, 5, 6, 7. Plus 1 is 8 divided by 2. So the median is the one right here in the middle. Okay, now it has asked us to add a new employee who has a 130-minute commute. So our mean is going to change to this, right? Does that make sense? I've already added all of these up. So all I need to do is now add 130 to that and one more on the bottom. So what's that? 304 divided by 8, which is 38. Okay, and if I add 130 up here to my list calculating the median, now we have 1, 2, 3, 4, 5, 6, 7, 8. 8 plus 1 is 9 divided by 2, 4.5. So the new median just moves over halfway to the next value, right? So the new median is 24.5. Right? So notice the difference in how much the mean changed versus how much the median changed. Right? So the mean is really influenced by extreme outliers. So then the question arises then, which measure of central tendency is better to use? The mean or the median? Well, really, it just depends. Okay, so if we look at this and we notice, look at this mean. It's 38, and here they're in order. There's only 2 values higher than the mean. So that's not really representative of the typical data. So in this case, the median's a much better measure of central tendency for this data set. Okay, one extreme observation can cause the mean to increase substantially, right? It went up by nearly 14 points. Okay, it went up by higher than what some of the data values are. Okay, but it really doesn't have any effect on the median. Adding a data value, no matter how big it was, is just going to bump the median over a slight bit every single time. If this person had, a 240-minute commute, right, it's going to really affect this, but it won't affect this any more than a 130-minute commute. So, in other words, the mean is sensitive to extreme values while the median is not. Okay, so a numerical summary of data is said to be resistant if extreme values, either very large or very small, relative to the data do not affect its value substantially. So the median is resistant and the mean is not resistant. Okay? When data are skewed, there are extreme values in the tail, right, which tend to pull the mean in the direction of the tail. So look at this. If we've got this skewed left, look where the median is up here, but the mean is pulled in the direction of the tail. If your data is symmetric, your mean and median are roughly the same. Okay, if it's normal, which we'll talk about later, they're exactly the same. But for symmetric data, they're roughly the same. Look at this. We've got it skewed right. We've got that tail, and it's pulled that mean towards the right. Okay, so a word of caution is in order. The relation between the mean, median, and skewness are just guidelines, right? I know, this is why we said lies, damned lies in statistics, right? The guidelines tend to hold up well for continuous data, but when the data are discrete, the rules can be easily violated. So you might be asking yourself, why would I ever compute the mean? After all, the mean and the median are close in value for symmetric data, and the median is better for skewed data. But the reason we compute the mean is that much of the statistical inference that we perform is based on the mean. Okay, and that's because the mean uses all of the data. Well, the median relies only on the position of those middle values, right? So like we said, if we had added a data point of 240, it really doesn't affect the mean. So that point doesn't even really get considered. I mean, the median. It really doesn't affect the median. So it's like it doesn't even get considered. It doesn't even change the median if you add a 130-minute commute or a 240-minute commute. But the mean reflects all of the data. So that's why we use it. But do be cautious because it is affected by those extreme outliers. Okay, let's see what we have now. So the following data represent the asking price of homes for sale in Lincoln, Nebraska. Okay, so there's a list. Find the mean and the median. All right, so if I'm going to find the mean to start with, okay, and since I know this cannot be every single home for sale in Lincoln, Nebraska, I'm going to assume it's a sample. And I'm not going to write that, but I'm going to go over to my calculator. And you should also, and take a minute, and I'm going to add all those up. Might take me a minute here. It's going to take me several minutes apparently. Let me put this pen down and then I can do it a little bit quicker. I was trying to leave that pen in my hand. Okay, now what am I? Okay. All right. Finally. Okay, so we got 5,266,244. Hopefully, I didn't make a entry error. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4 divided by 32 is, rounded to the nearest dollar, 164,570. Okay, let's do the median. And notice, lucky for us, they're already in order. And so there are 32 of them. So 32 plus 1, 33 divided by 2, that's 16 and a half. Right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So 16 and 17, I need to find the mean of 147,500 plus 149,900, and then divide by 2. So our median is 148,700. Okay, so we've calculated the mean and the median. Now, notice what it says. Use the mean and the median to identify the shape of the distribution. This mean is significantly higher than this median. So I'm going to say that means it's skewed right. Skewed right. Verify your results by drawing a histogram. Okay, let's see. If we were to draw a histogram of this data, and I'm just going to do a quick sketch, nothing official, just to verify. So I won't have my labels and things like we need if I was actually drawing a histogram for use as the histogram. But let's see, we go from, say, 80,000 to 350,000. Let's maybe go by 50,000, right? So let's make this 50,000, and we'll say in thousands. 100, 150, 200, 250, 300. Okay, we've got 32 values, so maybe, I don't know, I'm going to go by fives over here. I assume that 15 or 20 should be sufficient. 5, 10, 15, 20. Okay, none less than 50,000. 50 to 100. 2. So my bar is about this tall. Okay, up to 150. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Ooh, good guess. I meant for my vertical scale. Okay, and then the 200. 1, 2, 3, 4, 5, 6, 7, 8. So it's about right here up to 250. 1, 2. Ooh. Okay, then to 300. 1, 2, 3. And to 350. 2. Yeah, right? This is what we drew. If we were to draw through these metals, skewed right. Okay. Okay. A third measure of central tendency is the mode, which can be computed for either quantitative or qualitative. On the mean and the median, we need to be quantitative, right? But we could do a mode for qualitative. The mode is the most frequent observation of the variable that occurs in a data set. So your set of data can have no mode, one mode, or more than one mode. If no observation occurs more than once, then it has no mode. Okay, the data on the next slide represent the vice presidents of the United States and their state of birth. And it's asked us to find the mode. And I believe, yeah, it takes 2 slides to get this all in. And so I'm not going to list every one, but here's our states of birth: Massachusetts, Virginia, New Jersey, New York, Massachusetts. So some more states: New York, New Hampshire, New York. Okay, and here's some more presidents. And they've organized that for us, which is what we would have to do. I'm not going to physically do it, so thankfully they've already done that for us. And just a frequency distribution table. And if I'm looking for the mode, all I'm doing is seeing, is there one that occurs more often than any other? Right here. 8. So the mode of this data set is New York. Okay. If the data set had 2 values that was the same, let's say Texas also had 8 people that had been vice presidents, then we would call that bimodal. And if we were writing the mode, we would list both of them, and it's bimodal. If a data set has 3 or more numbers, we call that multimodal, right? But we usually don't, if you get more than 2, we don't really, it's not very useful for us, because it means, oh, if there's 3 or 4 values that had 3 or 4, we'll just use this as an example, states that sent the same number of vice presidents, then there's not really one that is occurring more often than the others, right? And technically you can have them, but we'll just focus on a single mode and bimodal for the most part, 2 modes. Okay, so here's a kind of a summary of the measures of central tendency, right? You've got your mean, whether it comes from population or sample, and it's kind of the center of gravity. You've got equal values on each side of it, whereas the median, you've got the same number of values on each side, not the same weight of numbers, but the same number of values. Okay, and the mode is the one that is the most frequent observation. Okay, let me know if you need any help.